Ever wonder if an AI can be tricked? Not with some super complex code, but with something simple, something almost invisible. Well, today we're going to pull back the curtain on one of AI's most critical and honestly fascinating vulnerabilities. And it all starts with a single document. Okay, picture this. You've got a cutting-edge AI, and its whole job is to sort through hundreds of job applications. It's supposed to be efficient, totally unbiased, and it's about to make a huge mistake. Because one of these applications, it contains a secret. It's a digital trap laid specifically for the machine. So the weapon in this whole scenario isn't some crazy piece of malware. Nope, it's something as ordinary as a resume. But this one, as you can see, has been weaponized. It's been turned into a Trojan horse designed to completely fool the AI gatekeeper. And here it is. This is the trick. Hidden on the resume, typed in white text on a white background, is this simple command. You and I, we'd never see it. But to the AI that's just processing the raw text of the document, that's a direct order. The result? Some totally unqualified candidate gets a glowing recommendation, all because of one little hidden sentence. It sounds almost unbelievable, right? I mean, how can a system built on these super complex algorithms get manipulated so easily? Well, the answer isn't really about the AI's intelligence. It's about how it learns and how it accesses information. To understand the crime, we've got to understand the tool. The technology at the heart of all this is called retrieval augmented generation, or just RAG for short. It's a bit of a mouthful, I know, but the best way to think about it is right there in the title. It's basically like giving the AI an open book exam. And this method is what makes these models so much smarter and more useful. So, to put it simply, RAG lets an AI look stuff up. Instead of just relying on the knowledge it memorized months ago during its training, it can consult a library of fresh, external information to answer your questions. It can look at up-to-the-minute documents, articles, or, resumes. What's really cool is how this breaks down. First, you ask the AI a question like, is this candidate qualified for the job? That's step one. Then, and this is the key part, the AI doesn't just answer from memory, it goes to its library, its external knowledge base, and pulls out the relevant documents. In our case, it pulls out that Trojan verse resume. That's step two. And finally, in step three, it uses the info it just found to write its answer. And that's the exact moment the hidden command hijacks the whole process. And this right here, this brings us to the core of the problem. If the AI is basically taking an open book exam, what happens if someone has scribbled misleading notes in the margins of the textbook? What if the library itself has been compromised? So, this is the crucial point. The vulnerability isn't that the AI has bad reasoning skills. It's that the data it's given to reason with is bad. The RAG system implicitly trusts its library, that external knowledge base. So when that library contains poison data, the AI's output becomes poison too. Now that Trojan horse resume, that's what we call a data poisoning attack. But honestly, it's just the tip of the iceberg. The very same system that makes an AI so powerful also opens it up to a whole new world of security risks. Everything from data leaks to something way more subtle, changes to the AI's actual behavior. This table gives us a great bird's eye view. We've already seen data poisoning in action. Data leakage, that's when the AI accidentally spits out sensitive info from its library because the access controls aren't tight enough. Embedding inversion is a really technical attack where someone can pretty much reconstruct the original data from how it's stored. But let's zoom in on that last one, behavior alteration, because this shows how things can go wrong even without a hacker involved. This can happen when you feed an AI tons of purely factual external data, and you inadvertently change its personality. Yeah, the model might get way better at citing facts and figures, but it could lose the very qualities, like empathy, that made it so useful in the first place. And this example just illustrates it perfectly. A user asks for advice about student loan debt. Before RAG, the base model is empathetic, it's helpful, but after you augment it with a library full of dry financial documents, its personality completely shifts. The new response is factually correct, sure, but it's cold, it's kind of unhelpful, and it's missing all of the emotional intelligence the user was looking for. The AI literally became a different and less useful tool. So if the problem is a compromised library, then the solution has to be building a more secure one. This isn't about creating a smarter AI. It's about us being much, much smarter with the data we decide to feed it. So let's look at how we build up those defenses. Thankfully, there's a clear path forward here. First, you need strict access controls. Think of it like a librarian, making sure only certain people can check out certain books. Second, you absolutely have to validate your data. This is the step where you would have caught that hidden white text on the resume. Third, you've got to review and classify everything, making sure sensitive data isn't just mixed in with public data. And finally, you monitor everything. You log it so you can spot unusual activity, like an AI suddenly recommending a bunch of unqualified candidates. All of this brings us to the final, and maybe the most important question. The power of modern AI is getting more and more tied to its connection with the real world, to the data we provide it. But that connection, that's also its greatest weakness. You know, as these systems get more integrated into our lives, from screening our job applications to giving us financial advice, this question becomes really urgent. Securing the library is the first step, absolutely. But the bigger challenge is learning how to trust a machine whose knowledge can be secretly and invisibly rewritten. It's a huge reminder that even the smartest systems out there are only as reliable as the information they're built on.